Okay. Looks like we're back online. Let's move this. Okay, good. We're set. 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 We're set.
Sometimes we call this the static side of the class.
Static side of the class, yes.
If you've used static fields before or static methods, this is the static side of the class.
Type.
Right, including things like this, style rule. Like these are just like variables that are hanging off of the class itself. And you can see those here.
Okay.
So one more type query we're going to touch on is indexed access types. These are pretty cool and the syntax, at least for me, is pretty easy to understand. I hope it is for you too. Let's say we have an interface called car. We've got our make, model, year, and then we've got an RGB color of some sort.
Okay, how do I increment code in NeoVim? I'm still learning NeoVim as well. So uncomment the code in NeoVim. We have to get better at this. We're going to practice our NeoVim skills, GCC. Do I have to select it? Do I have to select? Yes. Nope. I see. Nice. Okay. I see, which makes some sense, right? Okay. Wow. I see. This is nice. This is nice. At least I'm getting my groove back. Actually, okay. Okay. This is good. Okay. Nice. So we have an interface car that has make, which is a string, and a color. Color is also string. So one of the things I can even use to say color. Okay, but that's fine. Let's go back to the tutorial. Let's see what it is saying. What's the complaint? What do we have? What? Okay, we'll figure that out. That's not a problem. It's our first stream, so we're getting used to it gradually. So let's go.
But let's say we wanted to extract just the color of the car, like the type of this thing here. It's not a named type. There's no type alias we have access to, but we can use square bracket notation, passing in the string representing this property key, and look what we get. Red, green, blue. Indexed access type, meaning you're accessing within a type.
Access type. Index, just the way we... Oh, I see. Index access type, just the way we would access an array, right? Access an array. So we can say let what? Let's... Really? What's it trained on this data? Oh no, it was there before. So if we hover over here, we'll get... If we just hover over it, it's red, green, blue. Ah, I see. I see. Okay. So we can access the type like we'll do an array, like we do index signature. Not just index signature, but we are able to access the type using the index. Yeah. So we can even go a level deeper, right? We can do red. Look at the type. Look at the type. Okay, nice. Okay, cool. Nice.
Using an
That's a cool
index.
one.
This being the index.
This does index, yes.
You can use this for tuples as well, or you pass in a numeric index. And you can see we get real type checking happening here. Like this is a property that's not on the car. We're getting a type error as we should. Here's an example of a double dip, right? Like reaching into color and then getting the property red. What is the type of red? So you're going here, and then here, and then what's the type? And so we get a string.
It's a string.
There's your string.
It's a string.
And this is really interesting here. Projecting a union type through the index. Without hovering over this, what do you think we might get?
There's no year. We already have year, right? We have year.
Any ideas? Like what would make sense?
It should be a number or
year.
Color.
Other ideas?
Color, yeah.
A color or a string.
Color or a string.
Yes.
So you're both right. You get year or the type of year,
Which is a number.
but you also get this other type. The way I want you to think about this is it's as if we take each member of the union type, project it through the index access, pathway, and then we take all of those results and we union them together. Sometimes this is referred to as like projecting a union through an index access type.
Through an index access type. You can project a union through an index access type. So we can say car. We can say let's car property. Let's car property. I need to disable this. I'll need to disable this car, and it's a type of color, or which is also that's a union of year. Provided that we have year here. I see. Okay. So when we hover over this now, it's either a number or color, which makes sense. Nice. Index access type. Index access type. So we can create an interface and not really, yeah. Makes sense. But what if, let me try something that's not in the, let us try something. What if we do interface? What if we do interface? We do interface color. And this interface color, we are saying red is string. Will it work? Red string. No, we don't have to put. I don't think we have to do. Yes, yeah, we can put comma if we want, but normally we don't even need to do this, right? And we do blue, right? What if we do this? Yeah, a string. So is it okay? Okay, yeah. So when we now, can we also do? I doubt if it will work. If we say this is color, right? Good. Can we say no? I doubt if we can do that because it's not named, right? Can we say this still, aha, and do this. Still works. Still works actually. Still works. So we can still get the index access tab even when we create an interface for color separately, not necessarily if it's just not named this way. Makes sense. Makes sense. Makes sense. Makes sense. Makes sense. Good. Okay. Good. 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 Good.
You pass in two property names, and then you get back, here's your years type, and then here's your colors type.
Yes.
It's pretty cool.
Yeah.
Okay. Yes, sir.
One question from the chat. Could you clarify the difference between key of and type of?
Yep. Happy to go through that again. Key of. I'm going to add another example here. All right. So we've got a contact here.
Okay.
And if we wanted to get the names, like a type representing all valid names of properties.
That's a key of.
Like this.
Yes.
I want this type, but I don't want to explicitly define it. I want to get it derived somehow from this object.
Derived type, yes.
I would have some problems because like effectively I kind of want like object.keys.
Yes.
But I have a value here. I can't really like we'll call this try one. I can't do this. I can't do this. Contact refers to a value, but it's being used as a type here. This is a value.
Yeah, this is a value. Yes.
So let's replace this with type of.
Oh, yeah. That's a
Well, now I get a type. I get the type of this value. I've taken a value and I've obtained a type from it.
Yes.
Now, if I wanted to put them together, look at that. Name and email. So key of.
Object.keys.
It's object.keys for types.
Types.
Type of is get me the type of this value.
Object.keys of type. Object.keys of type. What are the three valid properties for keys in JavaScript? Go to what does a key of type query allow you to do in TypeScript? The key of is to obtain a type representing an object property name. Extract method. The key of no. Yeah, an object property name. Not it's used to obtain. It is used to obtain the type representing an object property name. Yes, that's it. That's true. What are the three valid types for property keys in JavaScript? String numbers and symbols. Yes, that's true. What is the primary difference between key of and type of in TypeScript? No. Yes, this one, yeah, exactly. Yes, that's true. Key of is used to extract property names. Why type of extract the type of the value? The value side, because we have two parts of it. We have the key and the value, key value pair. Type for key is key of type of the value side of things in a key value pair. Yes, that's correct. What can you do with an indexed access type in TypeScript? Create a new type. Yeah. You can use it. You can use it. You can access a specific property type using square. That's true. That's what you will be able to do. When using type of on a class, what type does it return? The type, yes, it returns the type, the static side of a class actually, not the type of an instance of a class. No, it returns the static side of a class, the static side of the class. Yes, thank you.
All right, let's put some of what we've learned here together and explore a use case. And I call this the type registry pattern. And we're going to look in a special little folder I've created here, just for this purpose, because I want to have multiple modules here. So let's look at what we've got. So in this type registry folder, I have a data folder and a lib folder, and then this index.ts. So what we want to do Well, I have to introduce a concept here first. Remember when we were augmenting the window object and we said declare?
Hold on. What are we supposed to do? I'm supposed to set our timer for the next work hour. What do we have here? What's happening here? What do we have there? What? Okay, cool. We'll just start this again. Yes, so we can track ourselves.
Global.
Okay, yes.
Let's see, it was here, the very bottom.
Yes.
Remember when we did this?
Yes.
This is sort of like saying, I'm going to provide some type information and I want to state which scope that type information should pertain to. Well, we're going to do the same thing here, but we can do it for a particular module. We can say, I want to declare some type information and it should be treated as if that type information were like literally in a different file. In this case, the lib/registry file. If I put an interface between these braces, it will be as if I took that interface and I went and I pasted it into the /lib/registry.ts file. So that's a new concept I want to introduce here. So what we're going to do is look at a use case where the key of type query is going to be useful, as well as an index access type, I believe, in order to solve a problem. And the problem we're going to try to solve here is building a data layer for a web application. And let's say it's my team's job to make sure that a bunch of other teams have an easy time fetching data. And I want to build a nice, easy-to-use function that takes the name of a resource to fetch and its ID and returns the right type. We don't know exactly what types users will need because maybe the teams that I'm helping empower, they're defining what book is and what magazine is. So I kind of need to set something up that allows very easily for new things, new types of records to be created, and they should kind of just work with fetch record. That's our goal. So here's our file structure. We've got a data folder with book and magazine in there. You'll see those are like trivial little classes where we define what a book is and what a magazine is. You can imagine that we get JSON back from a server and we sort of deserialize that JSON and end up like providing an instance of the class. Like that's what fetch record will return. A promise that resolves to an instance of that class, maybe. We've got a file called registry, which is where some interesting stuff is going to happen. And then index.ts, let's say that's the entry point of our program. That's where fetch record is going to be used.
Okay.
So let's go and look at a couple of these different files. We'll start with registry. So what we've got here is an empty interface. This is empty by design. And we've got our fetch record function. Our fetch record function takes an argument, which is key of data type registry end string. And that's just to make it easy for us to see what's going on here. And I'm actually going to comment a couple things out here so we can see a before and after more easily. So our starting point, arg is never. We haven't talked about this yet, but never it represents an impossibility. The set of values that corresponds to the never type, it is an empty set. Represents that nothing will make this happy. Now, if we put something in here, well, there we go. Arg can be foo. It's the key of this data type registry. And I'm just adding this so that we can see it easily. We'll see when things pop up. And then the second argument here is the ID of the thing to fetch. So what we're going to do, let's look at our starting point here where we're saying, I want to fetch a book, fetch record. It returns a void right now. Don't worry about that so much. But certainly, these are a bit of a problem, right? Like these aren't accepted values yet. And let me delete this. So what we can do is each of these models, like this class representing a book, can have at the bottom of the file a little module declaration. And it's using this concept of open interfaces, and it's saying, look, I'm going to add something to the interface.
Open interface is a way for us to extend an interface. We are going to data, right? Books and step into okay. What did we do? What we did was we went into we declared module. Okay, we are extending the module. We go to lib and we go to registry. When we do that, we create an interface called data registry. Okay, cool. Let's go. Okay. Yeah. Okay. That's it. This we declare the class. What did we do here? We declare the class. We declare the class book, and it has a method that returns 42, which is a number. At the same time, we are trying to extend an interface here, like we did before in one of our courses, right? We are extending this. Okay, go ahead.
And treat it as if this stuff was in the /lib/registry file. I want property name book, and here's book. It's the interface representing instances of this class, key and value. Magazine, we're going to do the same thing. Key is magazine. Here's an instance of magazine.
Okay. Yeah, done.
And now, if we look at index.ts, we don't get errors here. Look at that. We've got book or magazine. We get some type checking there. So you could imagine different people at the company, they're creating different resources like this. Like we could clone this. We could say video. This is duration. And this is video. Like all I have to do is that. I just create a new class. And because of this, it's sort of like just picked up for free. Look at that, book or magazine or video. So what I'm taking advantage of here is I have a central interface that represents sort of a registry that other modules are populating stuff into. They're adding their own entry there. And remember when we discussed, like there's only one representation of a type in memory when things compile? If we go to registry.ts, look at arg, book or magazine or vehicle or video. Now, this would work the same way if the code we're looking at right now were in your node modules folder. So you might ask, like, why would we want this? Why is this important? I could just go and ask teams to like add their entry into this interface, right? Well, if you're publishing a library, you don't necessarily know what the use cases of people consuming your library are going to do. You don't want them to have to sort of modify the library in order to make things work. This would let you build something that's general purpose, where you could sort of register things with a library, and then when the compile step happens, if you go into that library's code in your node modules folder, you'd see something just like this. The types are sort of fleshing out, even though if you look at this file by itself, there's nothing here that says book, right? It's been sort of injected because of these module declarations here. So what's happening is effectively we're using a type query here and an open interface in order to create this. I could take this one step further. Actually, we will take this one step further a little bit later. We will return the correct type, but we'll need generics in order to do that. LJ, I see you said the declare module thing is a bit confusing. If you want to learn more, intermediate TypeScript is a great course to take. We will get much deeper into module declarations there, and it's a more advanced concept, but I promise we will scratch your itch there.
Module declaration. So it's going to extend the class. We're going to extend it. Even though we did not have, so there is nothing like a book here. Good. Okay, so it's flash record takes in args, which can either be a type of registry. Registry, right? But where we are currently using it, we do this, refresh this. Okay. Is book a type of registry? Yeah, book is part of it. Data registry, it was extended. The data registry interface was extended. We have the data registry interface here, right? We have the data registry interface here. Makes sense. Nice. Okay. What is the purpose of using declare? What is the purpose of type registry pattern demonstrated in example? To define a static interface for all application data type, no, to limit the number. To create flexible, yeah, this is to create flexible data layer that allows easy registration of new resources. Yes, that's true. What TypeScript feature is used to add type information to a global open interface? Is it module augmentation with declare module? Type intersection? No. What TypeScript feature is used to add type information to a global or module interface? I'll just go for module augmentation. Yeah, it just comes natural. What does the never type represent in TypeScript? A type for undefined, a type, yeah, an impossibility. Yes, major an impossibility. What is the primary advantage of using an open interface for type registration? Yes, this was mentioned by Mike. Allows library consumers to extend types without modifying the original library. We do that every day at work. What TypeScript concepts are being used in type registration pattern? Type query index type, module augmentation. Yeah, type, yes. This is what is being used there. Type query index type, yeah. That's actually the chapter we just worked with.
We've dealt with function types and class types already to some extent. Let's take a step back and think about how we would type these things. Not how would we type a specific function, but how would we create a function type? Like how would we type a variable that is designed to hold a function?
Okay.
And I call these callables because we can call functions. So here's an example of a type. We're using an interface for this. It's a type that has a call signature. Look at these parentheses instead of square brackets as we saw for index signatures. What we're saying here is we take two arguments, x and y, both numbers, and we return a number. It's almost like that. Just delete the
callables. So we can use it to okay, let's try it out. Interface. Let's try it out. Let's see. Let's see if we can add two numbers. Add two numbers. More like the interface now becomes a contract for defining. It's now a callable A, which is a number. Makes sense. And B, which is also a number, right? I see. And now it returns a number. Okay, that makes sense.
word function and delete the name of the function. So this is a call signature. You can see here two number.
So that, you know that normally in TypeScript, right, if we want to say we create, this is interesting. If we say we want to create, let's say we want to create a function, this function should add to, the interface, I'm coming, let's do something. I said I'm coming, what am I even saying? What am I saying? Let me see. So if we say add two numbers, makes sense actually. This is a function in an interface for a function. It's called callable. Normally, if you want to, you can say add. You can just add two numbers. Normally, if you were to go the long route, you would do this. Yes, it's a function that takes in, you will now say A. Say A. You say A number, and you say B also a number. Right? And you say it should return also a number here. Yeah. 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 That should just return A plus B. Yeah, which makes sense. This is how you define it normally. But now, oh, I see. So instead of doing this, the typing for the function itself, I'll try this. I'll try this at work tomorrow. This actually makes sense. So instead of just doing this, we could just call it add two numbers. By default. Oh, because if you hover over this, you see this of type two numbers. By default. What? I never thought of it. Good. What time is it? Good.
Calc, and we can define this with the type alias as well. The key thing to look out for, which it takes forever for muscle memory to set in here, it's a fat arrow when you're doing a type alias, because that's kind of valid syntax on the right-hand side. And then, of course, in an interface, you use a colon. TypeScript will yell at you and help you get it right, but don't feel bad if you mix these up. So here we've got add and subtract. They're both two-number calculations, because these types are equivalent, like they're the same thing. And you see here, like we don't have to type X and Y, right? They are numbers. This is effectively now, we can use this as a type annotation for an arrow function. Two-number calculation. And then the right-hand side, we don't need any types. If you were going to type a callback that you pass to a function, you would use a similar technique. Because you want to define that this argument is of type function. Here are the parameters the function takes. Here's what the function must return. And you could use this. You could say, all right, I take as an argument a two-number calculation. Of course, you do get the type checking you'd hope to get. Like, you got to return a number here because it's part of this type, two-number calculation. Yes, sir?
You had sort of alluded to it back when we were talking about classes and inheritance and extends versus implements. That is an interface that syntactically cannot be implemented because there's no name to assign that's invocation.
Wow, that is a totally valid point and good insight there. Earlier, I did say interfaces describe, like an interface gives you the exact same constraints that you would need to use an interface to define a class, and like there is no way to make a class callable. Sorry, classes are callable. They just must be used with a new keyword, and we'll see that. But it would not be the signature. It would be something slightly different, trivially different. But yes, you cannot implement this interface. That's a very good insight. I'm not aware of other cases where that's true.
I think you may be able to technically implement it in JavaScript. I don't know if there's a way to describe the type information with TypeScript, though. Because I think from a...
Oh, you totally can.
You can return some callable, invocable thing from the constructor, which is gross, but...
Oh, I mean, you used to be able to call constructors without the new keyword very easily, and there was no disambiguation between callable and constructible. This is purely a TypeScript concept.
Callable is purely a TypeScript concept.
And this might have kind of been addressed there, or you might be getting to it, but could you explain why to use an interface versus a type with callables?
Yeah, that's a good question. I don't think there are clear advantages to using an interface or a type alias beyond interfaces being open, where if you wanted to describe like, I don't know, a function with some things dangling off of it, you would, I think you can still do this. Yep. But now, this isn't going to work. You'd have to do this. Yay. Oh, and all your inference is gone when you do this. So yeah, like technically, I mean, you could do that with a type alias as well. Like, I would say it just comes down to the open interface issue, which is rarely something you think about in a situation like this. If I were writing a library, I would always err on the side of interfaces to allow my downstream consumers a little flexibility.
Yep, and that was another comment, was types for normal projects, interfaces for libraries.
Sort of, yeah, in a lot of cases. Sometimes you write a library and you want to make really sure that nobody messes with a particular type, then you do want a type alias. So it's really, I would say it's more about like you allow for modification or not, and you sort of in libraries default to allowing modification, but there are valid exceptions. And same, on the app side, I would say it just matters less on the app side. You can go and mess with these types if you need to. So yeah, there are lots of places where like an interface or a type alias will do.
What is a core signature in TypeScript? That's a TypeScript concept, not a JavaScript concept. What syntax is used to define a function type in TypeScript? Let's see. It's a callable, right? It's a callable. Callable. That's interface or transfer. Oh yeah, makes sense. What is the key difference when defining a function type using a type alias versus an interface? Interface cannot define function. Interface has a lie. Interfaces are open and can be extended, while type aliases are closed. Yes, when you use type, it's a closed thing. Yes. What symbol is used when creating a type alias for a function? You have to use an arrow. Type alias, not interface, type alias. When defining a function type, how are parameter names typically handled? When defining a function type, how are parameter names typically handled? Parameter names must be specified. Parameter names are not required. Only the type. No. Let's do something first. To be able to, in order for us to answer that question, let's do. We are going to default back to B. We are going to default back to B. So if we save that, if we look at type two numbers, just for the so that we can answer that question properly. Type two numbers. True? Yeah. Type two numbers is that. So parameter names must always specify. Parameter names are not required. Only parameter names must match the implementation. I'll take the first one. I may be wrong, but parameter names are not required. Only their types. Really, I had missed that. What is a recommended approach to using type alias and interfaces in different contexts? Use interface for libraries to allow flexibility. Type aliases for more restricted definitions. That's what I will go for.
While we're talking about callables, let's talk about void. So if we look at this function, look at its return type. It's void. If you've gotten really deep into JavaScript, you may know that there is a void keyword in JavaScript. It means, in this context, ignore it. Like, it literally means do not consume the return value of this function. It is not what we would call a unit type, as null and undefined are, for one reason. Don't do this. So you could do this. Technically correct. So it accepts a void. It also accepts an undefined. Can anyone think of like why would it be important that void accepts an undefined?
Functions actually return.
Go back. We have to go back to that concept. I was trying to uncomment the code, so it didn't work the way I wanted, right? I see. Function. What did we say about void again?
In this context, while we're talking about callables, let's talk about void. So if we look at this function, look at its return type. It's void. If you've gotten really deep into JavaScript, you may know that there is a void keyword in JavaScript. It means, in this context, ignore it. Like, it literally means, do not consume the return value of this function. It is not what we would call a unit type, as null and undefined are.
Do not consume the return type. The return type of this function. Don't consume the return type. That's what it means. It's not the same thing as null and undefined.
One reason. Don't do this. So you could do this. Technically correct. So it accepts a void. It also accepts an undefined. Can anyone think of, like, why would it be important that void accepts an undefined?
Know what functions actually return when there's no return.
That is exactly right. It's what functions return when there is no return. So a void can be, the type void is itself and undefined. There are exactly two things that are allowed in there. Whereas null, if we were to do undefined here, or if we were to do, null, undefined is not going to do, this is not going to do, only this will do. We would call that a unit type. Like those literal types, right? It's a set with one thing in it. So let's look at these two examples here as an illustration of why it's useful to have void. This kind of demonstrates the need, the importance of void's existence. So we've got two functions here. We've got invoke in 4 seconds, invoke in 5 seconds. They're very similar. This is the only change between them, so don't stare at them too close.
Okay, invoke. Let's some comments.
Let's add some more stuff here. So, like, we kind of have a problem. I don't like that I can just, like, edit the serial number on. While we're talking about callables, let's talk about void. So if we look at this function, look at its return type. It's void. If you've gotten really deep into JavaScript, you may know that there is a void keyword in JavaScript. It means, in this context, ignore it. Like, it literally means, do not consume the return value of this function. It is not what we would call a unit type, as null and undefined are. For one reason. Don't do this. So you could do this. Technically correct. So it accepts a void. It also accepts an undefined. Can anyone think of, like, why would it be important that void accepts an undefined?
Know what functions actually return when there's no return.
That is exactly right. It's what functions return when there is no return. So a void can be, the type void is itself.
A void is what a function return when there is no return statement, which makes some sense. Yes. Nice. We have nice. Good. Since our AI stuff's good.
And undefined. There are exactly two things that are allowed in there. Whereas null, if we were to do undefined here, or if we were to do null, undefined is not going to do. This is not going to do. Only this will do. We would call that a unit type. Like those literal types, right? It's a set with one thing in it. So
Unit type.
let's look at these two examples here as an illustration of why it's useful to have void. This kind of demonstrates the need, the importance of void's existence. So we've got two functions here. We've got invoke in 4 seconds, invoke in 5 seconds. They're very similar. This is the only change between them, so don't stare at them too closely. We're going to create an array of values. And here, we're going to say invoke in 4 seconds, and then we're going to have pass in an arrow function, values.push 4. And if we do the same exact thing for invoke in 5 seconds, it type checks. And here's why. Most people don't think about this too much, but push returns a number. It actually returns a number. And so what we'd be saying here is, I'm actually returning something. And it's not undefined. It is not the specific value undefined, like as if I was doing this. I'm not returning an undefined. I am returning a number. I'm returning a number. Here, I'm also returning a number. But you know what? We're saying, don't worry about it. I don't care what the return is.
Yeah,
that's where you would use a void in place of an undefined. Do not create variables of type void. It really only has meaning in the context of the return value of a function. But it does have a purpose here. I mean, you could also do this. But then, of course, like within this function, you could say, you know, you could start to consume the value of this callback, and TypeScript would be perfectly happy to let you do so. When it's void, you won't get anywhere trying that, which is what you want, right? You want a helpful constraint there. Yep, LJ, you're right. Push returns the length of the array. Is it after the push? Returns the new length. Yep. That's a question in the chat. So we use void when we don't care about the return value, irrespective of a value being returned or not. Correct. That's correct. Void means ignore my return value. And one caveat here, if you do this, you'll be busted on this. So on the one hand, we have a callback here. Let me put this back. This is saying I accept a function with any return type, and please ignore it. Up here, we're saying I'm a function that should not return. Or I think I can still do this. Can I do this? Yeah, I can do that too. But like literally anything else, I will be stopped from doing.
Accept a value.
So it sort of has a similar meaning, but slightly different depending on what you're where you're defining the return type. If it is a function declaration, right? Remember, this is a value, it's a value of type function with a return type. So when it's used as the return type of a function declaration, it means I should follow through on a commitment to return nothing useful. At best, I return undefined. Either I'll create an undefined, which is weird, or I'll just write return, or I won't have anything at all, like this function right now. Like it's just pure side effects, and it returns when you reach the end of the function. Here, it's perfectly willing to accept a return value, but it makes sure that within the function that this callback is used, you're not doing anything with the return value. A little bit of nuance there, but they kind of both mean I shouldn't return anything interesting. Or whatever I'm returning is not interesting.
Makes sense.
That's void.
Makes sense. Makes sense. Makes sense. Makes sense. Makes sense. Make sense. Makes sense. Makes sense. Makes sense. Make some sense. Okay. What do we have? Okay, nice. Nice. That's actually makes sense. Make some sense. So the use of, I'm using makes sense. So what does the void type represent in TypeScript. Let's go back. What does the void type represent in TypeScript? A type used for declaring constants, a type for storing undefined variables, a type representing functions with no return value. Actually, yes. What does the push method return when adding an element to an array? The new length of the array. In what context is the void type most meaningful? Yeah, it's a return type for a function. That's the most useful. What does void signify when used with function callbacks? Ignore. You are to ignore. Ignore it. You don't bother.
Let's talk about constructables. So here's an example of a date constructor. This is exactly the same. This would be a call signature. Now it's a construct signature. Just add the word new in front of it. This is for newables, anything that you can use to create an instance. Classes, of course, are probably the first thing you think of, right? So here we can say, my date constructor is a date constructor. And I'm going to take date, not new date, but literally date. And now I can do this. And this is a date. This is now, this here, this is the interface of the class. So this is a construct signature. I would say this is fairly rare. It's common, more common certainly to write call signatures, because anytime you have a callback, things like that, if you're writing higher order functions, you're going to end up with a call signature.
Okay, makes sense. All right. I think that will be all for today. Call signature makes sense. Call signature, callables makes sense. Okay. Yep. You're sharpening it again. So. Okay.